About this proof. Here we go. Here we go. First thing I'm going to bring your attention to is the proof statement. Prove AB congruent to DC. Well, I can't prove that congruent unless the triangles are congruent. And we have, everyone agrees, we've got multiple triangles in this diagram. And I always say, pick the ones that contain the segments you're trying to prove. But there was an issue here. You could have, here's AB and here's CD. Aren't there multiple triangles there that contain that? Those as sides. So what you could have seen first is these two. Maybe the one that looks like the bow tie there. Maybe you tried to prove those triangles congruent because they contain AB and CD. So when I did that, here's what I said to myself. Well, the only thing really I can put on here, I have vertical angles, right? Those are congruent. They tell me lines are perpendicular. Are those two right angles here going to help me in the proof? Nope, they're not. All right, and it's pretty sad if you guys didn't do this last night, by the way. People are copying this down right now. Just throwing that out there. AC. Everybody see AC? Is that a full side in this triangle right here? This triangle right here, is AC a full side? No, it's not. So that's not going to help me. So none of the givens help you. The only thing I can mark are the congruent angles. So is there any way I'm getting those two triangles congruent? Absolutely not. So where is the other pair then that contain AB and DC? Name the triangles up here that contain AB and DC. Other than the ones I just showed you, we cannot prove congruent. Let's go right to it. Here we go. Oh, all right, never mind. Let's try that again. What are the other pair of triangles here? Don't help anybody out either, please. Here we go, 20. What's the other pair of triangles? Here you go, everyone. ABC, this triangle right here contains AB. And this triangle right here, DCB, contains DC. So if you can prove those triangles congruent, AB and DC are congruent by CPCTC. How do I prove them congruent? Here we go. I already have AC and BD, so I have a side. I also have right angles here and here, one in the red, one in the yellow. What else can I have? What else can I mark on my diagram that wasn't given? 11. Well, not even there yet. Not even there yet. I'm trying to look for more sides or angles. I have a pair of right angles. I have two sides that were given to us. Is there any other pair of sides or angles up there that are congruent? They do share a side, don't they? Okay, there we go. So I can say BC. So now here's my question. Let's take my yellow triangle. I have AC, BC, and this right angle here. Is that right angle in between those two sides, yes or no? Here we go, 9. Is that right angle in between AC and BC? No, it's not. So side angle side's out. So the only other thing I have close to side angle side is HL, because I have a right triangle now. So here's my question. What is BC acting as far as hypotenuse and leg go? What's BC acting as? Here we go. 5. Leg. That's the leg. And what's AC and BD acting as? AC and BD. Come on. Here we go. 18. So you're telling me I already have hypotenuse, and when I write it in my proof right now, I'll have the leg as well. So I have HL staring you right in the face. And so I don't get suckered into doing the rest of the proof for the people who didn't do it. Here we go. What else should you have in your proof? I'm not writing it down, though. 15. Okay. What else should I have in my proof now? We know it's HL, so 1. Why would you want to do that? Is that an angle in any of the triangles I'm proving congruent? Yes? No? Okay, so why do I need it?
So you can have HL because you need another leg. Or I don't know.
What's HL stand for? In my red triangle right here, where's the hypotenuse? In the red triangle, where's my hypotenuse? Already got it. What's my leg in that red triangle? I already wrote it down. I already have the hypotenuse and leg. So now I'm asking what else needs to go in my proof before I say the triangles are congruent.
Another leg.
What's HL stand for?
Hypotenuse leg.
Hypotenuse is already given. Leg I already wrote down. I do not need anything else. Well, I can't write the right triangles unless I have what? Right triangles have? So what do I need to put?
They have right angles?
Yes. This is an HL proof. You need right triangles, correct?
Yes.
You need the hypotenuse and the leg.
They have right angles. Perpendicular lines form right angles.
Okay, that's what I'm asking. You don't need to get back at me because you didn't know the answer to begin with. Okay? Sorry. We good? That you need the right angles. All right? Sorry, if your number comes up again, I won't bother with you. Don't worry about it. So after I have the right angles put in, 9, what else do I need?
You have to say that the triangles ABC and DBC are right triangles.
You need to say the right triangles, then I can say they're congruent by HL, and then how do I end this proof? AB congruent to DC by CPCTC. Questions? Okay, let me see it. And I know it's not going to sink in until next week when we actually do them, but this is nothing compared to what we're doing next week. Okay? It's nothing compared to what we're doing next week. So keep that in mind if you struggled with this one a little bit. Okay, here we go. We are all done with methods of proving triangles congruent. Now we got to focus on the individual different triangles. This one is isosceles today. Okay, here we go. Who's got 6? Okay, Nick, what do you know about an isosceles triangle? 2 sides are congruent. That's what most of us know about an isosceles triangle. 2 sides are congruent. I'm going to add to that right now. If 2 sides are congruent, so are the angles across from them. In an isosceles triangle, you locate the 2 sides. Not only are the 2 sides congruent, but the angles across from them are congruent. So in my diagram right here, I have AB and AC congruent. We know 2 sides are congruent. But now what I'm going to tell you is across from those sides are 2 congruent angles, B and C. Okay, so now we got a new definition of isosceles. Not only are 2 sides congruent, but 2 angles are congruent. And where are those 2 angles located? Always, no, we are never saying on the bottom, because watch, they are not the bottom 2. Here you go. Everyone agree that's isosceles? Congruent angles aren't on the bottom, though. They're going to be, ready? Across from the congruent sides. So they're not necessarily on the bottom. Everyone good? Okay? And I can say the reverse. Let's say you give me one triangle where the 2 angles are congruent. It's isosceles, and the sides across from them are congruent now. So going in reverse. So if I give you in a triangle, 2 angles are congruent, the sides across are congruent as well. Before I get into the vocab, let me squash something real quick. What I just discussed with you only occurs in a single triangle. One triangle only that occurs in. So for instance, if I give you 2 different triangles where those sides are congruent, you cannot tell me those angles are congruent. This theorem happens in a one and only one triangle. Do we see the difference here? Just because 2 sides are congruent doesn't mean the angles across from them. It's got to be in a single triangle only we work with. Anything you want to ask about that theorem? Okay, now we got specific names. The sides have a name and the angles have a name in an isosceles triangle. The angle that's not congruent to the other two. Okay, so the angle that's in between the two congruent sides, it's the outcast angle. All right, because it's not congruent to the other two. The name of that angle is called the vertex angle. Vertex angle. That's the non-congruent angle. Right? It's in between the two sides that are equal. Okay, that's called the vertex angle. The sides that are congruent, these two congruent sides in an isosceles triangle are referred to as the legs. The unequal side, the outcast of the three, the unequal side is called the base. And again, guys, we are not in middle school anymore. Base does not mean bottom anymore. All right, base does not mean bottom. Here you go. Let me go back to my example down here. Here's my base right here. Okay, the base is the non-congruent side. Right? And then finally, what about the two congruent angles? Oh, there we go. Two congruent angles are called base angles because they're surrounded by the base. Okay, base angles. Questions on those vocabulary terms? This is going to be quick today. All right, now you got a diagram below. Do you guys see multiple isosceles triangles in that diagram? Multiple ones. Name a triangle, name at least one triangle on here that's isosceles before we start answering any of the questions. Here we go. 8.
Triangle RUV.
RUV. Everyone agree? That's isosceles. Give me another one that's isosceles. Remember, it's not two congruent sides anymore. You can do two congruent angles to make it isosceles. So I got RUV. Got it. Give me another triangle. 6. VWS, because it's got two congruent. It's got two congruent angles. Is there any others in here you see? There should be one more isosceles triangle that you see. You see the two small ones and yes, why? Because it's got two congruent angles. There you go. So I see 3 isosceles triangles in this diagram. All right, now let's answer the question. Angle R is congruent to what other angle that is not marked? So don't tell me S, please. Do not tell me S. So look in a single triangle that contains angle R. Everyone look at one and only one triangle that contains angle R and tell me if you find another angle that's congruent with it. And again, don't give me S. It's already marked. Give me something that's not marked. So angle R should be congruent to 12. Angle, need more specific than that. Good, because when you say V, I don't know which V you're talking about here, Emma. Okay, see why you need 3 letters. So RV, U, yep. Before we say Y, does everyone see that? It's in one isosceles triangle. And again, what's the theorem say? What's across from the congruent sides? Congruent angle. So here's the theorem we're going to write. In a triangle. And we'll put this into the reasons column starting Monday. Before I write the rest, that's got to be there. Because this does not apply to a square. It does not apply to a pentagon, an octagon, only a triangle. So in a triangle, congruent. What did we just prove here? 2 congruent angles. So good. Congruent angles are across from what? What did we find out? What did we find out all today here? In a triangle, congruent angles are across from congruent sides. There we go. Okay, do the same thing now for RT. RT is congruent to, again, make sure the side you give me is also in that same triangle RT is in. Okay, so I got RT and, here we go, 14. RT and TS, got it. Because the big triangle's isosceles. So across, take a look. Across from angle S is RT. Across from angle R is TS. Same way in a triangle. Now this is going to be slightly different. Because what did we just prove? Side, so I got to put the sides first. Okay, you know, whatever you just proved, that's what should go first in that theorem. So congruent sides are across from congruent angles. And then finally, how about VW? Look at a triangle that contains VW. See if there's any congruent angles across from them. If there are, what's across from the other congruent angle? VW and what do we have? 6? WS. Yep. In a triangle, how do I start this one out? Congruent sides again, because that's what I proved. Any questions finding the sides or angles in an isosceles triangle? Okay, I'm going to there's a couple things you guys need to add on because I didn't put a couple angle measurements in here. Okay, for the first example, this angle right here is 70 degrees. All right. And I don't believe on number 2 right below it, I don't believe I marked these congruent. So mark these sides congruent for me in number 2. Mark those sides congruent. Okay, you are with your group right now for the next 3 or 4 minutes. Find X and Y in both diagrams and be able to back yourself up with some kind of theorem or fact. All right, so go ahead and work with each other. I got some isosceles triangles going on here, so go right ahead. Okay, here we go. I'll probably have to take Y first for number 1. All right, I'm going to take Y because Y leads you to X. So, okay, here we go. What do we end up with here? Here we go. 6. 70. Go ahead, Nick. Explain to your classmates how you got 70 for Y. There you go. This is an isosceles triangle. 2 sides are congruent, so across from those congruent sides are congruent angles, absolutely. So that one's going to be 70. And then how do we end up getting X, even though it's in the other triangle? How do we get X? 4? Thank you. Okay, how do we end up getting X? 13?
You want to know what it is, or how do we get it?
Well, I want to know what it is, and then how do we get there?
40.
Okay, how do we get there?
Vertical angles are
Okay, they are, but how'd you know that vertical angle was 40?
because if you add up 70 together and then subtract that from 180, you get 40.
So 180 degrees in a triangle, that gave me 40, which gives me that one is 40. Any issues with that one? Okay, in number 2, it's isosceles, right? So what's across from those congruent sides? Congruent angles. Again, you got to take it as the whole triangle that's isosceles here. So this angle X is going to be congruent to whatever that angle was right there. And I'll take X or Y for this one, doesn't matter. X or Y. 11, what do we have?
X is 70.
Okay, how'd you get 70?
In a straight line, it's 180 degrees, so 110 minus 180.
So that angle's 70, and then just what we talked about in a triangle, congruent angles are across from? Congruent angles are across from? Congruent sides. So everyone all right how that's 70? It's an isosceles triangle. And then how about Y? A couple different ways you could get to Y. Here you go, 1.
Y is 20 because there's
180 degrees in this triangle here. Or we could have said, what type of angle is 110? It is exterior. You guys remember what an exterior angle was equal to? The sum of the 2 remote interiors, which would be 90 and angle Y. So 90 plus what would give me 110? It would be 20. Other questions? Okay, let's go. Pick up a book, your Chromebook, whatever you got. Get going on the assignment.